All right. So you go. What you got? Which part are we looking at?
1663.
Ooh, yeah. Okay. 60 looks like this. This one here?
No.
Oh, section 2.1?
Yeah.
Oh, okay. Oh, okay. So, I mean, to be honest, we haven't even gotten into chapter 2 yet, officially. Right? We just come. So you can get ahead all day. Dear God, not a problem. But I normally hold off on questions until I've gotten into it. So maybe today through the lecture it'll get answered, and if it doesn't, you can just ask it again and say, I got the same question.
Okay.
Okay. Cool. Anything from chapter 1 stuff? Yeah.
Could you do problem number 12 real quick?
Oh, this kind of thing came up a couple of times. This one here? Right, so 9 minus y squared if y is -5. So so I'm going to rewrite the problem. So I'm going to write 9 minus, and I'm going to replace y with -5, and then the square is still there. So what's -5 squared?
Positive 25.
Positive 25. So this is 25, and then there's a 9 minus. There you go. So this negative cannot cancel that negative. What operation would that be if I make these two become a plus? What am I actually doing with them then? Multiplying. And what comes first, multiplication or exponents? Exponents. So that's why I do this, because that's the next thing to do. So I replace what that is, and I write the other stuff. Yes, ma'am?
Okay, is the answer a negative number?
All day long. Think about, there's a couple ways to do this. I like the visual of if you're 9 feet up and you dig 25 feet down, right? If you dig 9 feet down, then you're at 0 level, you're at sea level. Right? And then how much more am I going to go down? 16. So I actually end up, what sign does the 9 have on it? Positive. What sign is the 25?
Negative.
When they are opposite signs, you subtract and put the sign of the bigger one on. What's 25 minus 9? 16. What's the bigger one? Negative.
Okay.
Is that cool? Yes.
Can you also go over number 34?
Was it a question about this here or different?
No, I was just going to ask what is the commutative law?
Oh, okay. Hold on to that. Which one?
Number 34, please.
Oh. All I want you to do, the highest dive is 177 feet.
That would be the positive.
Yeah, that's up. And then the other one is the record for the deepest dive.
So it's negative.
Yeah, that'll be negative.
That's it.
That's sort of related to the 9 feet up versus 16 feet down idea, yeah.
Okay.
Another way to think of this also is money is really good with this kind of problem here. If I got $9 and I owe you 25, I can't pay you all the way off. I'll give you all my money. I still owe you 16 because I paid 9 of my debt off. So 25 minus 9 tells me how much debt I still have. We can calculate debt pretty well, unfortunately. College students' lives are basically ruled by that, so you should know negative numbers pretty well. I love when the bank is like, you used all your money up, so we're going to take some of your non-existent money from you. Well, thanks for that. You charged me for no money. That's great. Okay. I remember those days. Anything else from homework stuff? Oh, your commutativity, right? Commutative law. So you have commutative and you have associative. Those two. It's easiest to describe and to compare the two. Right? What did you guys do to get here? You commuted. So individuals commute. I like to say individuals commute, parentheses associate. What the shit do I mean? Well, here's an example of commutative law. I'll actually moved from here to here. This is obviously equal. Is that cool? If you add 4, 7, and 2, it doesn't really matter what order you add them in. Addition is commutative, multiplication is commutative, subtraction is not, division is not. Is 8 divided by 4 the same as 4 divided by 8? They're not the same. So order matters for those. Addition and multiplication, it don't matter what order you add or multiply. But what moved? What moved? The 7 and the 4, the individuals moved. That's why it's commutative. So what would it look like if it was associative? It would look like that. Did any individuals move? No. What moved? Parentheses. So parentheses associate. Individuals commute. It's just a name of a property that some systems and some operations have and some others don't. They both say the same thing. You can add and multiply whatever order you want to. But they say it in slightly different ways. So this could be, for multiplication, this would be 4 times 7 times 2 equals 7 times 4 times 2, right? You could just put a times here and it'd be the same idea. So addition, multiplication, we should already know it doesn't matter what order you do those in. They're all on the same level. Now watch. Subtraction. Is subtraction commutative? Is this a true statement?
No.
Dear God, no, right? This is,
8 of 2.
and this is
2.
2. So it's not commutative. It's also not associative for the same reason. Same thing with division. It's not commutative or associative. Poor little dude. Is that right? Okay. Yeah. Anything else from homework stuff? Chapter 1? Yes. Oh, so there you go. That's exactly this. So just like this here. If I gave you this, can you use commutative law to rewrite that? So instead of putting 4 times xy, you could put 4 times yx. And for associative, what actually has to move are the parentheses. Yeah, so that's the idea. You say, use those rules to rewrite this. So commutative, you better make sure that individual things move. I could also do it this way, which is really kind of weird looking, so I don't blame you if you don't do this. See how the individual 4 moved? Well, that looks really freaky. So if nobody did that, I'd be fine, right? But mainly you just go boop, and that's commutative rule. Is that decent? Yes.
36.
Oh, all right. Okay. This is really becomes big later. What does this mean? Can somebody read that? Yeah, good. Somebody had a question the other day I didn't get to for everybody. But I say -3 is less than x, right?
Right.
Which is different from that phrase we talked about, just less than. 3 less than x would be x minus 3. 3 is less than x would be 3 less symbol x, right? So the is less than makes it this symbol. Greater than, sorry. I'm thinking about, how am I going to turn this around? I'm getting ahead of my brain. So a real quick way to remember which is less than, which is greater than. Which one looks like an L that had a rough day? This one. Right? Yep. So that's less than. And you got the alligator crap. I don't know if you guys heard about the alligator one to eat and everything. So yeah, that is greater than. How would I turn it around? I can't just flip these around. I have to flip the whole thing mirror image. If -3 is bigger than x, x is less than -3. That's all I want. You just have to mirror image it. If you just flip these around, those are totally different statements. It's the same thing as saying, I am taller than Joe, so Joe is shorter than me. So the sign's got to flip too to make it the same. I like it. Is that all right? Obviously, we're going to get deeper into inequality stuff later. This is just making sure you know what the symbols mean.
I just had a question on number 16.
Oh, 60, the one I was trying to do earlier. What about it? Or just So
So I kind of get the basic idea of like the wording, but this one in particular just.
is this the one at the 4 times 18 minus 8, or?
No, 16.
16, okay. I keep wanting to do that problem. So 16. Oh, yeah. All right. So this is 15 times the difference. Where do you go? Of Brent speed and the wind speed. They want you just to write this in Mathish. Right now it's in English. They want you to translate it into Mathish. Am I doing 15 times a thing, like a single thing? So this isn't 15 times b minus w sum. This is 15 times the difference. I got to write the difference first, and then do 15 times that difference. So what letter are you going to use for Brent speed? No way. What letter are you going to use for wind speed? And what's the difference between those mean? Yeah. And then that difference, you have to do 15 times it. So if you write this, why is that not right? This is the correct answer. This is not, because this would be the difference between 15 times Brent speed and the wind speed. Do you guys see how that's changed? The difference between 15 times Brent speed and the wind speed. This one is 15 times the difference between Brent speed and the wind speed. You're going to write that first and then multiply it by 15. Yes?
Does it matter if you put the B or the W first?
Totally.
In
Yes.
the parentheses?
So the only phrase in English that has to get turned around, like we learned yesterday, is less than. Right? The difference between 10 and 8 is 10 minus 8. Fantastic. The quotient of 10 and 8 is 10 over 8. It's as it comes. The 10 less than 8 is 8 minus 10. Right? But again, that's funky-ass English. Right? That's really what it is. So the only one that turns things around is the less than, to make it match with what English means. I like it. I'm really curious about other languages and how they handle that, if it's different. But right now, all I know is it's English's fault. Okay. Yes?
On number 15, would you just like automatically get rid of those three to be left with negative 2 over 7 rather than doing the...
Oh, hell yeah. So that's why I did that example in the warm-ups where you definitely reduce first. So the stuff you got to multiply is smaller numbers. Yeah. It's harder to reduce last because then your numbers get all big. So might as well kill what you can first. Yeah.
One I had the most problem with was 56.
Oh, yeah, that one looks kind of long. All right. So here, if you haven't tried this yet, take a minute and try this one. 56 looks like this. The cube. Yeah, minus 5. Yeah, it looks like somebody just didn't know when to stop, right? But I feel like that's enough. So what saves your ass all the time is order operations. When there's multiple parentheses, you start on the inside. If you follow order operations, it's exactly what would happen. I have to do inside these parentheses first. Inside there, what do I have to do first? Inside parentheses. I kind of like start over again, right? So I do the innermost parentheses first. On the way, you could do a couple things, but let me just do this really one step at a time. And what is 4 minus 7? What comes next? After parentheses?
2.
Exponents? 11. What's negative 2 cubed? And in here, what would I do next?
Multiply the 2 and the negative 3.
Yeah. So do 2 times negative 3 minus 6. All right, let me stop there for a second. So this is negative 3. This is negative 6. This is negative 8. So I just keep replacing that with better names. Negative 2 cubed is better known as negative 8. It's a more useful form. Now, what can I do? What's like the last thing I'm going to do? From the beginning, I should know this. The very last thing I'm going to do. That subtraction right there.
Yeah.
Something minus something. I'm going to do that last. I like it. So what does that mean? What can I do here? Yeah, what's this?
Negative 2.
Negative 2. And what can I do in here? I get,
3 minus 1.
yep, there's 2. Minus 6 is
Negative 4.
negative 1. So 2 minus 6, negative 4. And now what would I do?
You multiply the negative.
Good. I have subtraction. I have multiplication, so obviously I'm going to do multiplication next. I could do this, but I'm trying to get you guys away from that. This is negative 5 times negative 4 is positive 20. And of course, what's negative 2 plus 20? 18. Is that right? Is that? Are we all right? Okay. All right. Okay. I think I'm almost done all of those. All right. I'm going to get into chapter 2. Unless there's any burning questions left. I think there's enough questions. I want to kind of end a bit early so I can take you guys on a little mini field trip. Show you where some of the tutoring centers are. Point you in the direction of my office. I'm not going to make you go all the way because it's basically the other side of campus. I want to get into chapter 2, and I'm going to use, I warned you, I'm going to use this dude, which you can get in the bookstore. And to be honest, all right, before I go in that green book, some of the explanation about how to solve equations doesn't capture the reality of where equations comes from. Equations come from observations we make. So you guys ever get weather updates in any fashion? Are they ever exactly right? You don't understand how many equations have been made relating all the variables that affect weather. So what I'm thinking about is I used to live in Virginia and Florida, and one thing they have that you guys don't hear, that we don't, is hurricanes. So if it's been a while since we had rain, I always root for them to come up, aha, but they never do. They just kind of go, aha. I kind of root for the tropical storms that get to us nowadays. Give us rain, please. But you'd always, whenever there's a hurricane, you might have noticed they always have this kind of thing. They're like, we think it's going to be here, but it could be anywhere in this range. So in Florida, Virginia, we just always had tape up, just in case. We just leave the tape up on the windows, just in case. It's because they're averaging all these different outputs from the equations that relate air density, air temperature, water temperature, what direction the jet stream is in, all these different things that affect formation and development of hurricanes. So whenever I'm trying to explain how to solve equations, it's not showing you yet where they come from. We're just learning how to solve them. In the real world, equations set themselves up. We see relationships between things, we set up their relationship mathematically, and then I can input values. Well, the water temperature now over there is this. Plug that in, oh shit, category 5, run. So we want to set the thing up so I can input what the conditions are to make predictions for that one example, right? All right, so hopefully understanding that. This is not where equations come from, but this does help us understand how to solve them. What is x? What's the idea of x in general?
Unknown.
An unknown, a variable. What could it be? Anything, really. Sometimes the answer for x could be nothing, but it's like what makes something work. So what could x be in general? Any damn thing. So give me what you want x to be for right now. 2. I love it. That's crazy. That's what I was thinking. So if x is 2, somebody help me out. What is 4x? Okay, doesn't that just make sense? Don't you naturally do the same thing to both sides? Because if x is 2, 4x better be 4 times what the hell it was. That's why you do the same thing to both sides to keep it true. All right, somebody help me out. What's 4x plus 3 then? 11. So now, hopefully you understand, if you're given this equation, or if the observations you made says this is the relationship for my variable, how do I solve it? I undo all the shit somebody put on top. I'm trying to get x unburied. X is currently buried underneath the 4 and a plus 3 and all that kind of shit. So that's the basic idea of solving equations. I would undo the plus 3 first. If I subtract 3 from both sides, I can see what 4x has to be. In fact, somebody tell me, what do you add to 3 to get 11? What do you add to 3 to get 11?
8.
So 4x has to be 8, don't it? Isn't that what the algebra says here? Okay. So really, when the equations are simple, there are actually simpler ways to look at them. We still develop the processes because that can make this equation really ugly. Not just because I'm a math teacher and we like to do that to you, but because equations that work in the real world are naturally uglier, right? So we have to know how to work with them. And then, of course, I want to get rid of this 4. I'm always doing the opposite thing, so it cancels. And I have to do it to both sides to keep it true. So then we uncover our x is 2 again. When x is 2, this statement is true. That's what that means. I like it. So let's look into the green book here. Let's turn this stuff on. You probably want to point it that way, Jeff. That's a bit huge. There you go. There you go. All right. Can you somebody? I think it's that middle one. Yeah. All right. So if you don't have this yet, get it. This is going to be like the main place for notes and stuff. Okay. So solving an equation. Solution is a value for the variable that makes the original statement true. That's what it means to solve an equation. So to check if something is a solution, we just replace the variable with it because it's supposed to make it true when you put it in. So can you take a second and check? Is 7 a solution to this? If you replace x with 7, is it a true statement?
Yes.
Yes. 7 minus 15 is negative 8. Yes. So 7 is a solution to that. It's the only solution. Bless you. All right, try the second one. So again, everywhere you see x, you replace it with the proposed solution. If it's a true statement, yes. If it's not a true statement, no, it's not a solution. Yeah, so if I plug a 3 in here, 5 times 3 minus 1. A lot of times you put a little question mark for when you check it. Doesn't really matter. Equals 2 times 3 plus 6. 15 minus 1, is that 6 plus 6? Is 14 equal to 12? No. Therefore, 3 is not a value that makes that equation true. It's not a solution. Does all this sound vaguely a little bit familiar? Okay. All right, I like it. By the way, I want to say this. There's a lot of different backgrounds in here. So if it's been a while since you took math, do not be discouraged because the person next to you is like, I know all this shit, come on. Because that person maybe took calculus and they're just like, it's been years and they're coming back here and they know all their, I mean, what do you do for them? I mean, I took art class in college. To be honest, I paint decently well. I was surprised. But I came in there not knowing shit. There's people around me that I've been painting since I was 2. I'm like, good for you. I don't know what the shit I'm doing. So I came in with they've already done all these paintings and they're getting grades. So I'm like, how fair is that? I'm having to do mine from what the shit. It's just the different backgrounds. You can't compare yourself to other people. You're better than them at some stuff. They're better than you in some stuff because of shit. With that said, though, if I'm going too fast, slow me down. If I'm going too slow, deal with it. Right? Okay. So there's 2 main principles, and I want to kind of see. They kind of jump right into this, dude. Let me give us a couple examples here. Besides that, we're going to do this one in a minute. This looks almost exactly like that. So if I had this, let me give you a couple examples. If I had, whoa, dude, let's crank that brightness down. All right. If I had 4m equals negative 12, how would you solve that? Yeah, so basically it's always the idea of do the opposite operation. So I've got, since the unknown is being multiplied, I'm going to divide by that thing, right? So try to get the unknown by itself. So if I divide both sides by 4, pop, m equals negative 3. I like it. What about if it was b over 7 equals 3? Yeah. Because the current operation is division. So what are you going to do to undo that? Multiply by the thing I don't want. Right. Again, I'm trying to unbury my poor variable. It's stuck with a 7 on it. Let me multiply by 7, both sides, to keep it legal. So b is 21. I like it. So what they're jumping into is combining those, which is basically what this was too. How would you solve this dude here? Yeah, you definitely don't, you almost never divide first. If I divide by 3, which I see I want to do sometime, if I divide by 3 right now, do you see all the fractions you make? You don't need any of those fractions, right? So I'm pretty good at math. But even I am not going to do something that makes fractions, because fractions is a place I make mistakes more often, right? Same thing with negative signs. If I can avoid negative signs, I do, because that's an easy place for us to make mistakes. So yeah, you're right. The first thing we're going to do, subtract 5. And what happens? Yeah, I get 3x equals 6.
Divide 3 both sides.
So we get x equals 2. I like it. Yes?
For example, you did the fraction. What would you do if it were like 2b over 7 equals?
Oh, then you would do both things. Since you asked, let's do that. Let's see, where do I have a question? Whatever. So his question is, what if you had 2b over 7 equals what, Jeff? I don't know, Jeff. 8. Sure. Well, all right, let's think about it as two kind of steps here, because I have something divided by 7. How would I kill the 7?
You have to multiply 7.
Just like we just did. We
Right.
multiply by 7.
Yeah.
I also have 2 times something. How do I kill the 2? Divide by 2. So I can multiply by the reciprocal of this. So what am I going to do? Both sides. I've got to multiply by 7, divide by 2 on both sides. So now I've done the same thing to both sides. That maintains the truth of it, right? Those both cancel. So b equals 8 divided by 2 is 4. 4 times 7 is 28. Now you could, let me do that problem again. Right, so we got that there. I'm zooming away this shit. do that problem again. This time I'll do one thing at a time. Right? So I could just do times 7, because that immediately makes it look better. If it's an equation, you can kill all your fractions. That's fantastic, because I'm allowed to do stuff to both sides. If it's just a fraction sitting there, you can't kill it. Too bad for you. But if it's an equation, I can kill fractions, because I can multiply by their bottoms.
The chapter 2 homework is 2 over 7 equals x over 3.
Oh, okay, I know. We're working up our, we're working there. All right. So here, if I do the same problem, I multiply by 7 first. I get 2b equals 56. And then I have to divide by 2. B equals 28. The same thing we got before, because I did multiply by 7 and divide by 2. Here I just did it all at once. There's not a damn thing wrong with you doing it one step at a time. Yeah?
So when I was trying this yesterday, when I would multiply by the reciprocal, on the other side, I would turn the product that was already there into a fraction. Try to find
Oh, sure.
that works as well.
You don't need LCD though, if that's what you were about to say.
Okay.
You just reduce and multiply.
Okay.
Yeah. When you multiply, you don't need LCD. It's only when you add subtract that you need like terms. Yeah. Okay, cool. We're working up to that one homework question. We're not quite there yet. So here, let's see, let me give you something. What do you do when there's a variable on both sides, like down here? Trying to solve for z. There's a z on both sides of the equation. Yeah, so you want all your variables on one side and then all the numbers on the other side. So you kind of pick a side. What I always try to do is I try to keep the thing with the variable positive. That's like I said earlier. I try to not let there be negatives when I can. So I wouldn't subtract 5z, I would subtract z. That would keep the z stuff positive, right? Control what I can. Lord grant me this serenity. Let's see. Minus z, minus z. Now, I'm going to show you an example of how you're your own worst enemy if you don't keep this organized. Some of you guys just kind of throw parts of the equation down, you put stuff together, and then you kind of try to get an answer out of it. Oh my God. Shit just kind of goes from one side to the other. Just the 5 is like, I want to go over here now. Yeah. You can't move to the other side unless you get it there by doing the opposite operation, right? So be nice to yourself and keep things organized. So what's left on this side?
-5.
Negative 5. These kill each other. There's the equal sign right there. 5z minus z.
4z.
Now who's in the wrong place? That negative 3 is in the wrong place. So what do I do? Add 3. I love it, because the opposite of subtracting 3. Adding 3. Pull this up here. So what do I get? Negative 5 plus 3? Negative 2 equals
4z.
Now this is where people just don't even do the work. They let their brains say, oh, the answer is negative 2. Yay! And that's wrong. Right? You don't look at the numbers and go, I know how those numbers work. No. What would I have to do to get z by itself? Divide by 4. Right? So what is actually the answer then? Yeah, negative 2/4, which is? Negative 1/2. You guys all right? Is that cool? So get your variables on one side, everything else on the other side, and you almost always divide last.
Sometimes in the book they have the negative sign on the numerator, and sometimes they just have it in the middle.
Oh, yeah. So, so this is the same thing as this. The only place we don't put it is in the bottom because it gets lost down there sometimes. That's the only real reason. Yeah. So both of these mean negative 0.5. If you put in the calculator, they both come out to be negative 0.5. So they both represent the same number. So would 1 over negative 2, but like I said, the negative would get lost. I like it. When we get to this graphing, then I'm going to want to put it on the top or the bottom because that means rise or run, right? Rise or fall, run back forward, run backward. So it depends on where you put the negative. Right? Well, right now it's just a number. Who gives a shit? On top, out front, but not down below. Kick ass. All right. Ooh, all right. Oh. Try to do what you can on this one. This is one extra step above what we just did. If you have the book, I'm on page 3. The green book. Yeah. Do you want me to come over there?
Yes, if you don't mind.
Yeah,
I
okay.
thought they were working on it.
Okay.
Oh,
This is an equals. Oh, so yeah, you got your equals in this green. There's your negative 5. I like it when you add and read. That's the only thing in the wrong place.
14 minus 5 and then negative.
Equal. So look, watch it. Negative 5 equals 14 minus 3.
So I have it in the wrong.
Yeah, that is on this side, and then what's left on this side is there. And the only thing in the wrong place now is that number. No. Because you want your letters on one side. So there's your letters. Numbers on the other side. So you see what I mean by the only thing in the wrong place is the 3. Because it's with the letters right now. It's the zeros. So you got to get those suckers over there with the other numbers. Weird. So you put variables on one side, numbers on the other side. Sure. And the last thing you do is almost always divide. But how is the 3 and the how is the 3 positive and the 5 positive? You add 3, but the 5 is negative. That's the only mistake. No. There's a negative 5 with a z next to it. So when you subtract the z, you're left with a negative 5. Yeah. That negative is not on the z, it's on the 5. Yeah. All right. So the only extra, so what we keep doing is we keep adding one extra layer. So this one, there was nothing to distribute. I can start moving numbers and letters. This one, there's one step before I move stuff, and that's distribute. So if I distribute the 3, what do I get? Distribute the 2, I get. Now this one might freak you out a little bit. I do not blame you. I like this problem though. I would. What'd you guys do next? Who did something next? I love it. Add the 12x. You got to get the x's together. So now I get pop 18 left on that side, and over here I get 18 plus 6x. Now the numbers, which number's in the wrong place? Yeah, that 18, right? So subtract 18, subtract 18. This is where some of you guys are just kind of like, I'm done with this one. But what do you get? 6x equals 0. Now, what's funny is, now watch. If the problem was 6x equals 12, what would you do? Divide by 6, and your answer would be 2. It's amazing. What if the problem was 6x equals negative 24? What would you do? So does it matter what I make this number? No. So if it's 6x equals 0, what do? Divide by 6. Don't let the 0 tell you what to do. You're like, there's 0. You do what I say. So I'll do this side. Here's x. What is 0 divided by 6? 0. If you think about it, notice right here how it says 18 minus something equals 18 minus something else. Well, no. The only way that this could be true is if 18 equals 18 and this is 0. I can't subtract two different things from 18 and have it come out to be true. They actually both have to be 0. But if you don't see that, that's fine. The algebra gets you there. Yes?
You always have to use the variables first?
No, you don't always. On this problem, though, if you move the 18 first, you get a little bit freaked out, but just remind yourself, don't get freaked out until you get all your numbers on one side. They disappear. But then all your variables have to be on the same side, too. So if I were to do that problem again, let me just pick it up right here. So if I chose to do the 18s first, This is where people start dividing and doing all kinds of weird shit. But are your x's together yet? No. So then you add 12x, get your x's together, and then you end up right where we were. But I know this doesn't look like what we're used to, but the process doesn't care. I like to teach this. I'm going to say this a lot this semester. The process doesn't change. The process don't care what just happened. We're like, oh, my numbers went away. The process is like, what? No, get your x's together. It's like, everybody calm down. So if my x's aren't together, I get them together. And then this does not tell me what to do. This does. Because I want x by itself. So what's telling me what to do is the thing that's making x not be by itself. So don't let 0 tell you what to do. This tells me what to do. Divide by 6. Ooh, x equals 0. Real quick. What's the difference between 0 divided by 6 and 6 divided by 0?
You can't divide anything by 0.
Why not? What is 6 divided by 2?
3.
Why? Because 2 times 3. So there's a number defined in such a way that when I multiply by 2, I get 6. That number is 3. So you guys see where I'm going.
Yeah.
For this to be true, I have to put a number here defined in such a way that when I multiply it by 0, I get 6. Is there any number defined to do that?
No.
So we call this undefined. That's why it's called undefined. Because it just ain't defined. There's nothing defined to do that, so it is undefined. You guys cool with that? You guys have heard that word before?
Yeah.
Did you ever ask, why the shit is it called undefined? You just went, gotcha. But do you understand now? Does it make sense? That's why we call it that, because there's nothing defined to do that. This has an answer, because it's a number defined to do this. Ain't no number defined to do this shit, so it's undefined. This, all day long, is here. If I got no money, and there's 6 of us, how much do we all get? Nothing. This one is, if I got $6, and there's nobody, not even me, what the shit's that? That's undefined. What are you talking about? All right, I know I just freaked you guys out, but that's another reason. That's a physical reason why this is undefined. If I got 6 apples, and nobody's there, not even me, and you're like, what the shit are you talking about? Who's got the apples then? That's a weird-ass situation. Undefined. Maybe.
It happened in Avengers. Half the universe was gone. So there's no apples.
Oh, the Avengers? Oh, God. Don't even start. Spider-Man somehow holding on. Oh, my leg just went away. I don't feel so good. Oh, spoilers. Sorry. Thanos wins and shit. It's fun. But, you know, they're all in the spirit realm and all that shit. All right. Let me see. Oh, let's. So going isn't really going today. We're gonna do
So
something.
the 0 up on top would be considered all real numbers, or what?
No. If I have 0 divided by something that's not 0, 0 divided by 5,
Yeah.
the answer is 0. Because what's the number that when I multiply by 5, I get 0? 0.
Yeah, but when you had the equation, which was 6, anything would still come out to 0. So you can take all the numbers.
No, be careful. All right, so what we just had was 6x equals 0. What's the only thing I can multiply 6 by to get 0?
0.
So the only answer to this, the only answer is 0. That is the only answer.
But this, before the x, any number could be. It could be 5, 6, 7, 8, 9, 10.
But when I'm solving an equation, yeah, x can be 5 or 6 or 7, sure, in general. But what's the only thing x can be to make this true? If it's 5, 6 times 5 is 30. That ain't 0.
No, I'm talking about the 6, before the x. It could be any number.
Oh, I see what you mean.
Yeah.
This doesn't matter that it's 6.
Right.
Yeah. In fact, I can write this. ax equals 0. Where a is anything. Any
Right.
number. How do I solve? X equals 0. I think I just blew some of your
So
minds.
that would be all real numbers?
What's what you're saying? I wrote a 6 here. Could it have been, stay with me now, bring your head back. There you go. If that was a 7, what would I have done? Divided by 7, I would have gotten 0. If that was a negative 27,
Negative.
I would have divided by negative 27, I would have got 0. If it was something, I would have divided by that thing, and I would have gotten 0. That's your point. I love it. Stretching? Or answer a question? Yes?
Yeah, 703 that we just saw. Instead of adding 12, I subtracted. I
Added 6?
Yes.
So then you got a negative 6 here, right?
Yes.
So then you divide by negative 6, and your answer is still a 0. So there are some different paths to take to solve an equation, but whatever path you take, you must get the same answer as somebody else. That's why people think math is black and white. I don't blame you. Right? You always think there's only one answer to something, so math is black and white, but this is like the bare beginnings of math. When you get further into math, you get into the fuzzy logic. You guys remember Jurassic Park and the whole like random, you put the bead of water, he's flirting with the girl, but oh well. Still was a true thing. Put the bead of water, which way is it going to roll? Well, that's completely random. That's you can't know that. That's fuzzy math, right? Anyway, sorry. Let's think about that. We're going to deal with absolutes here, okay? No fuzziness. But let's do this. I too want to try to take all of you on a little field trip. If you can go out the door and start this way really slow. And let me run out in front of you. Everybody with me? Huh? Yeah, take your stuff. Because I can't lock the door. So if you value what you have, you should take it. No, we're not coming back here. Yes, sir. What do you need?
Just something that they cost.
Oh, at the end I'll go to my office so you can talk to me as I walk.
I have the class like 5 minutes after this one, so
Oh, well, we're way early. So
Yeah,
we
okay.
should be good. Oh, sweet.
Can I take a picture of the book, please?
This one? Or the other one?
Yeah. You guys are going to the library, right?
Yeah, they're both in the same spot in the library, in the 108
I'm
section.
going to use the restroom. I'll meet you guys there. So on YouTube, I just put your name.
If you go to my website, you got the syllabus, right?
Yeah.
If you go to the website, there's a link to the YouTube stuff. On YouTube, my name is Waller is me. I'll have to go there, but you can just click on the link on the website. Oh, yeah. Just our first quiz is going to be Monday. I think I said that yesterday, but I'm going to remind everybody tomorrow. All right.
Question.
Yes.
Here's your cell phone.
Oh, thank you.
I